1-4 fractions part 1. Our learning targets, we got two of them, is that I am learning to identify equivalent fractions, and I am learning to add and subtract fractions. So we have today's date, our 10/6/20, we have our name, remember we got our calculators at Desmo, so we're all good to go there. Now as far as it goes, we are going to look first at equivalent fractions. So fractions such as, so go ahead and write that out for me. So fractions such as, and then that way we can go ahead and kind of give some examples. Alrighty, so fractions such as 1/2, 5/10, and 7/14 are called equivalent fractions. So you all write out that sentence right there where we have the three fractions we're given, 1/2, 5/10, 7/14. While you all write those out, kind of think about it. We know fractions, we've seen those before already this year, but what does that word equivalent mean anyway? What does equivalent mean in math? Equal. So like they're all equal to each other. So if I say 1/2, 5/10, and 7/14 are equivalent, which basically means they equal each other, how can we see if they all equal each other? Now that's the trickier part. We know that they're equivalent, but how can we prove that they're equivalent? So in order to do that, we're going to have to kind of check them and say, like, will 1/2 reduce any more than what it is? No. Can 5/10 reduce? Yeah, what's 5/10 reduce to? 1/2, because 5 can go into 5 one time, and 5 can go into 10 two times. Alright. What about 7/14? Can that reduce? Yeah, what will that reduce to? 1/2 as well, because how many times can 7 go into 7? Once. And how many times can 7 go into 14? 2. So if you look at them, once we reduce all of them, what do they all reduce to? 1/2. So basically, to be equivalent, they're all going to reduce to the same fraction. I didn't give myself enough room there, did I? I'm sorry. So they're all going to reduce to the same thing. That's how we know they're going to be equivalent, because they all gave us 1/2. And we know that technically we could say 1/2 equals 1/2 equals 1/2 because they're all the same. So that's how we have our equivalent fractions. Now for this next part, we just have to remind ourselves how to reduce fractions. There's a couple of ways we can do it. One way is to remember, what does a fraction bar actually mean? Divide. So you can do numerator divided by denominator. Is it bad I have to sound it out when I spell it, when I write up at the board? So it's like numerator and denominator divided by. I forgot to say divided by denominator. So denominator. There we go. Now the other way we can do it is, for those of you who've watched the videos all the way through for me while we were virtual, you will realize Desmos has a fraction button. So Desmos' fraction button, he'll also reduce them. So to just kind of give us that example, if you all can for me in your Desmos calculator here, let's go ahead and put in like your 5/10. So you can do 5 divided by 10. Oh, there we go. Oh man, try that again. 5 divided by 10. And it gives you 0.5, but what's that button right beside of it tell us to do? Convert to fraction. So you hit that button, and what does it tell us it reduces to? 1/2. You can also hit the fraction button here, a over b, and put in there like 7 over 14. And it goes in and tells you 0.5 again. Hit that convert to fraction button, 1/2. So it goes ahead and reduces it for you. As far as it goes, I know like Desmos are teaching you that way because we can all access that while we're at home. So as far as using the calculator part, anybody have any questions? Alright, so now on your own, let's see a couple of examples and see about reducing them. So it says reduce a given fraction to lowest terms. So if you want to, I'll let you go ahead and do the first two on your own, come around, check those, and then I'll let you do that last one all together. So take a second, reduce 8/36 and 36/84. It's all up to the same speed. There, grab our calculator over here. And we have 8/36. I'll count the fraction button. So we have 8/36. 6. There we go. We want to convert it to a fraction, so it gives us 2/9. So over here, we're just going to write 8/36 is equivalent to 2/9. And then do the same thing for our 36/84. So 36/84. Convert it to a fraction and gives us 3/7, and we're all good. There we go. Now, make this page large because we have one last example. We have 3 to the 4th power times 5 to the 3rd power times 7 all over 2 to the 3rd power times 3 times 5 to the 5th power times 7 squared. So, as far as it goes, what do we need to do first? Well, no, I'll give y'all time to write it down there. So take a second, write it down. What do we need to do first for it? You got it. You can do the exponents first. So of course, you go through there and use the order of operations. So there's no parentheses. But we know we have 3 to the 4th power. What is 3 to the 4th power? 3 times 3 times 3 times 3. 81? Yeah, thank you. That's right. For some reason, I heard something else. Alright, math's making me hear not as well. Do you all feel that same way? Alright, so 5 to the 3rd power. 125, very good. All times 7, there we go. And now 2 cubed, so 2 times 2 times 2. 8 times 3 times, what's 5 to the 5th? Ooh, 5 something? 525? I don't know. Maybe bigger than that, but something in thousands.
3,125.
Thank you very much. So much for my guessing. And now 7 squared. 49. Now I'm going to need your odds up because that's a big multiplication. So 81 times 125 times 7.
70,800.
Make sure I wrote that correctly for me. So 70,875. Now the bottom's going to be an awfully large number as well because it's 8 times 3 times 3,125 times 49. Now copy numbers for me. What are we going to get?
3,675,000.
Even? Very nice. There we go. And now, once again, go back to Desmos. Put in that really, really large fraction here. Let's see. Probably be easier if I show you that number. There we go. So we got 7 $26,875 divided by 3,675,000. One more zero. There we go. Convert to a fraction. You get 27/1400. So you guys got two? That's a really big one, but that's okay. 27/1400. There we go. So that one made us pull in a little bit of our order of operations and made us use our Desmos calculator. So as far as it goes, take a step. So we are given the 24x squared y to the 4th z to the 7th over 18 x to the 5th y squared z. Now, these have certain directions, but we took a little bit of them back when we did our 1-2 polynomial rules. In that we had to remember when we multiply polynomials, we multiply the coefficients and we add the exponents. So does anybody remember what we do if we're dividing? You got to subtract the exponent. So step 1, we're going to divide or reduce. I always like to say reduce because sometimes they don't divide out nicely. So divide or reduce coefficients. So coefficients always do what they're told to do. That's that number in front. That's been a little while since we took those notes. So number in front. There, front. There we go. And now you got it. We subtract exponents. Of same variable. So the first part is what we just did. We just looked at how to reduce fractions. So, on your all's end, go ahead and do that. What is 24 over 18 reduced to?
4 over 3.
Huh?
4 over 3.
4 over 3. Thank you very much. Because let's see. 6 can go into 24 4 times. 6 can go to 18 3 times, so we're all good. If you notice, did I make a little short fraction bar? I'm going to make a long fraction bar. That way we have all these variables we got to place somewhere. Now this next part does come from algebra 2. It makes us remember a little bit of our algebra 2 points. I have an x squared over an x to the 5th. I need to subtract their exponents, but which way do I subtract? Do you subtract numerator to denominator, or denominator to numerator, and how can you tell the difference? So now I'm thinking about algebra 2 monomial rules now. Alright, this will help out my kids had me for algebra 2. Where should the x go, top or bottom? Think about it. I know. Let's see, we did it around Christmas time last year, so it's been a little while. So I have an x squared over x to the 5th. Bottom. Why do we say the bottom? You're right. Huh? You got it. If you do 2 minus 5, it's going to be a negative 3. But if you do it the other way and say, oh, come on. Oh, man. There we go. And say 5 minus 2, you get a positive 3. So as far as it goes, you always keep the variable where it has the higher exponent. So keep variable where it had the higher exponent. So the easiest thing with that one is just say which one has the higher exponent, the bottom or the top? Bottom. So what we're going to do is we're going to keep x in on the bottom, since it's bigger on the bottom, and then just say, what's 5 minus 2?
3.
You got it. Now, which y is bigger, top or bottom? Top, so y is going to stay on top. And now we subtract. What's 4 minus 2? 2. And now, here's my favorite part. I have z to the 7 over z. So which one's bigger? Top. But how many z's do I have on the bottom? 1. So I'm still have to do 7 minus 1 and get what? 6. And there we go. Now I'm going to leave that one up there. I'm going to leave our rules, but I'm going to write one more down here. That way we can see another one along with our original one. So we'll have a negative 5 x to the 5th y z squared all over 15 x y to the 4th z squared. So you all take a second, remember those rules. So first things first, we're going to divide or reduce the coefficients. So what's my coefficients? You got it, so put that in the calculator. What is negative 5 over 15 reduced to? You got negative 1/3. And also, in Desmos, if you remember, you use the minus symbol and then long fraction bar, so negative 1 over 3. Now, same steps with our variables. We want to pick which one has the higher exponent, so x on top or x on the bottom? Top. So we'll have 5 minus, how many do we have on the bottom? 1. So what's 5 minus 1? 4. So we get x to the 4th on top. Now, same thing. What is our y? Bigger on top or bottom? Bottom. So y to the 4th on the bottom. Now we're going to subtract bottom to top. So 4 minus that 1 is going to give us what? 3. And now I purposely picked this one out for us because it's z squared over z squared. Very good, but if it's on the same on the top and the bottom, it cancels out because what's 2 minus 2? 0, so it cancels out because we have 0 z's left. I made my fraction bar way too long. Let's make it a little bit shorter. And now we'll throw a box around this guy. And I'm going to give you one to try all on your own. So I'll put it right beside this one. That way, once again, we can still see some of our rules. So, example 6. We have 14 x cubed y to the 4th z all over 49 x to the 5th y z to the 3rd. There we go. Let's real quick check this one. You all done a great job. I get all this up on the same pace. What is going to be our 14 over 49 reduced to? 2/7. Alright, which x is bigger, top or bottom? Bottom. So 5 minus 3 is 2. Y is bigger on top, so y on top. And now 4 minus 1 is 3. And then lastly, z is bigger on the bottom, so z. And then 3 minus 1, 2. So make sure your answer looks like this one. Take a second, see how you did, see what maybe you need to make any corrections on. So are we all good? Now this next part, guys, in our very last little bit, is mostly just calculator work. So like this just goes back to Desmos and making sure we know how to use Desmos right. So it's adding and subtracting fractions. So we just ended on what number? 6? So 7. So we have 5/12 plus 1/4. Once again, making sure we just know how to use our technology properly, because I realize, I don't know if you all realize this, but you all can actually go to Google and literally just type in 5/12 plus 1/4, and Google can add fractions for you. Desmos is nicer because it still looks like a fraction. You know, the yellow calculators, those of you who used them last year, you know, that control divide button, use your fractions, you can add fractions on there as well. But the big thing is just making sure we know how to do these inside Desmos. So for 7, we got 5/12, so we're going to hit the fraction button. 5 over 12. And then plus, and our other fraction's 1/4. So fraction button, 1/4. And that gives you a decimal, but we're going to hit this button because we want to convert it to a fraction. And what does else going to give us? 2/3. So 5/12 plus 1/4. Did I put it in? Yeah. If you didn't get that, just double check your answer, or double check like how you typed it in. You may have like a little mistake. Usually I make mistakes there. So we have 2/3. Alrighty. Same with our next one. We're just going to go to fraction, 2/3. So 2 over 3 minus, and then fraction button again, 4/5. So 4/5. Hit the convert to fraction button. Get -2/15. So take a second at 8. Make sure you get that answer. -2/15. Alright, now our last example, 9. You do that one all on your own. I'll come around and double check it. 7/12 plus 3/16. So 7/12 plus 3/16 in Desmos gives us 37/48. And we're all set. So now,